so we're basically trying to store carbon to counteract global climate change caused by human sources as opposed to the natural sources. But I
Right.
mean,
And
so
yeah,
how does that work as far as are we also trying to counteract the Earth's forces at all? Like, would that benefit us or not really?
well, I could go at length on the carbon cycle. By the way, my background is in geology, and I was teaching climate change at the University of Michigan. In fact, I was teaching the graphs that Al Gore ended up using in his movie, An Inconvenient Truth, which show, well, some of the graphs were the increase of CO2 measured in Mauna Loa, Hawaii from 1950 forward, as well as some of the climate reconstruction graphs that were pulled out of ice cores in Antarctica. Um, Several of my colleagues actually worked on that work in Antarctica, namely Richard Alley. He's a big name in the climate change debate in academics. There's certainly a natural carbon cycle, and I think that's part of what people have to understand, because when you see counter arguments to the idea of human-induced climate change, they'll say, well, volcanoes emit CO2, or there's CO2 exchanging with the ocean, and there's, all these different factors. And yeah, that's in there, and we accommodate that. There is an uptake of CO2 into the oceans, and we can enhance that. In fact, one possibility of increasing carbon sequestration naturally has been to fertilize the ocean. And I'll talk about that a little later, I think. Kind of a spin-off of what I'm trying to do. And in fact, in some of the things, the permanent sink for carbon is as carbonate mineral. And that's actually what I'm trying to promote.
Right. So that's like seashells, right?
Well, yeah, you could call it seashells. It's solid carbonate mineral, whether that's in seashell or just lime deposit on the seafloor, it's lime mud. But most of it is either macroscopic shells, but a large majority of it is actually microscopic shells, plankton and zooplankton producing shells that are precipitated, as we call it in geology, the ooze, right? So we deposit ooze on the seafloor, and that's ultimately carbon getting onto and getting deposited onto the seafloor is carbon's ultimate fate on Earth, at least in the million-year time scales. Now, then at that point, carbon then is subducted and re-released as volcanic CO2 gas coming out of volcanic vents. But by then, it's had interaction with the mantle and everything like that, so it's got a completely different chemical signature. So, and then of course, some of the carbon, particularly marine carbon, gets incorporated into organic carbon, which ultimately becomes either methane. There's methane deposited on the seafloor, and of course, ultimately, there's also a source of petroleum. That's ancient organic carbon that's been buried as well. But carbonate mineral is the permanent sequestration of carbon, for the long-term storage of carbon out of the Earth's atmosphere and into the ocean.
Yeah. So you said one way of sequestering carbon is to basically to feed the ocean in some way, but in your website in general, you talk about using salt water to store carbon in general. Is that the same, or is that a different process?
Well, yeah, mine is an industrial mimicking of that process, and really kind of a mimic of what the Earth does. It's an industrial mimicking of what the Earth does naturally. It raises the pH of a fluid. So the first step in the process of electrolyzing seawater is to produce a base. In the case of the seawater electrolysis, it's sodium hydroxide, and then you aerate the water with CO2, and that forms a dissolved compound of carbon called bicarbonate. And bicarbonate is very stable in water, and calcite is in shells, and it's in microscopic organisms, as well as in just naturally occurring carbonate precipitate. So if you can get calcite to be precipitating on the seafloor, that's ultimately putting carbon to rest on the seafloor. Now, the industrial process is that I'm trying to promote is two phases. And by the way, I should say I don't have the patents on these. I'm working with a company that has patents on these. Actually, there's several that are doing variations on this theme, and I'll get more into that maybe a little later. So the idea that I had would be to take this carbon sequestration process and marry it, couple it, what is the word that I want, to the desalination plant, the desalination proposal. There's a site in Huntington Beach, which is site of the AES power plant at Newland and PCH, and Poseidon, which is a water company, is building a desalination plant. I don't know, they're going through various approval processes right now with the county and everything, but it's been on the books since like 2000. But I think they've been given the final go ahead to build this plant now, and they've built them before in Carlsbad, California. And anyway, the plant, the desalination plant, is sitting right on a power plant. So it's sitting right on a CO2 emitter. They're sharing the property. And then the desalination plant is drawing ocean out of the old water intakes for the power plant and then sending the brine out to sea. So rather than having these two polluting industries sitting side by side, the idea was take the CO2 emitted from the power plant, run it through this electrolyzed salt brine that you can produce from the brine that's produced from the desal process, and in the process store carbon, or at least sequester it into solid form. So that's the mimic of the Earth's carbon cycle, is to try to get carbon into bicarbonate, into either in solution as bicarbonate or ultimately into solid carbonate mineral.
Yeah, which is also a naturally occurring process, obviously. Oh, yeah. Like you go to the beach, you see the seashells, right?
Yep.
So we talked a lot about carbon in general and carbon sequestration, but I've heard actually that methane stores more heat than carbon. It's just in a smaller quantity in the air. So
That's
can you
correct.
tell us a little bit? Can you tell us a little bit about methane as a greenhouse gas and kind of what threats that produces?
Well, I can talk a little bit about it. Yes, it's a much more efficient greenhouse gas molecule, but you said it, it's in a much less concentration than CO2. So much so that it really doesn't factor in at least human production of methane. I mean, there's some methane byproduct from animal operations, for instance. And there's certainly natural gas production. But one of the biggest threats to the climate right now is as the northern hemisphere begins to thaw, you're releasing methane that was locked up in the permafrost. So the reason methane's coming back into the fore is it's a feedback. Think of a snowball rolling down a hill. You know, the bigger the snowball gets, the bigger the snowball can pick up snow. And that's the same kind of thing that's going on with, as the climate warms, it is affecting the northern hemisphere more than any other place right now. And that is then melting permafrost that had locked up methane. And so now methane is going up into the atmosphere in ever higher concentrations than it had been before, and is a much more efficient greenhouse gas. But if we want to look at the human sources of methane, the largest sources, of course, natural gas production from petroleum, that's methane, CH4. Or, any operation that involves, animal waste. Cafes, what are they? Concentrated animal feeding operations, or CAFOs, not cafes, CAFOs. Concentrated animal feeding operations. You want to eat at a cafe, not a CAFO.